5F, identities on binomial coefficients. We're just going to work through the questions. It says consider the identity 1 plus x to the power of 4 equals. If you try and expand that, isn't it 4c0 x 1 to the power of 4? You know how to expand this? Isn't it 4c0 1 to the power of 4 plus 4c1 1 to the power of 3 times x? You know how you drop a power and plus, isn't it 4c2 1 squared x squared? So I'm not bothering with the 1 squared. Plus 4c3 1 times x cubed plus 4c4, there's no more ones and you'd have x to the power of 4. So it says consider that identity, prove the following and explain each result in terms of the row indexed by the n equals 4 in Pascal's triangle. Okay? First question, it says so we're doing part A. It says by substituting x equals 1, show that 4c0 plus 4c1 plus 4c2 plus 4c3 plus 4c4 equals 2 to the power of 4. So you take that expansion, and now if I go sub x equals 1, what do I get on the left-hand side? 1 plus 1 to the power of 4. So what we've done, we've written out 1 plus x to the power of 4 and written out the expansion. You don't have to, so it would be 4c0, 1 to the power of 4. I haven't written the 1 to the power of 4, okay? Then 4c1, 1 to the power of 3, x to the power of 1. I'm not writing my 1 to the power of. It's silly to write it, okay? So if I substitute x equals 1, what do I get? 1 plus 1 to the power of 4 equals 4c0 plus what? 4c1 times 1 plus 4c2 times 1 squared. See what I'm doing? Plus 4c3 times 1 cubed plus 4c4 times 1 to the power of 4. And if you simplify that, what do you get on the left? You get 2 to the power of 4 is equal to 4c0 plus 4c1 times 1 is 4c1 plus 4c2 plus 4c3 plus 4c4. So we've just proven that result. Now, they might say to you, prove that result, but they won't tell you to substitute x is 1. You'd have to know 1 plus 1. They might say prove that 2 to the power of 4 equals that. You would write the expansion of that out and you would see if I substitute x is 1, I will get that. Alright? Are we okay? Now, look at part B. It says by substituting x is negative 1. So by substituting x is negative 1, we have to show that result up there. This one. Let's just substitute x is negative 1 into the original expansion, into the original binomial expansion. So if you substitute x is negative 1, I'm going to call this equation 1. Alright? So I've got substitute x is 1 into 1, substitute x is negative 1 into equation 1. So part B, substitute x is negative 1 into the expansion and show that result. Let's see what we get. What do I get if I substitute x is negative 1? 1, come on, plus negative 1 to the power of 4 equals 4c0 plus 4c1 times what? I'm substituting into this. Yes. Plus 4c2 negative 1 squared plus 4c3 negative 1 cubed plus 4c4 negative 1 to the power of 4. No. You don't start with no. Definitely not. 1. 0 to the power of 4 or just 0 is 4 choose 0. What else do I get now? How do I simplify 4 choose 1 times negative 1? Minus 4 choose 1 plus, what's that? Isn't that just 4 choose 2? What's the next one? Minus 4 choose 3 plus, what's negative 1 to the power of 4? No, it's not. Negative 1 times negative 1 times negative 1 times negative 1 is just 1. Plus 4 choose 4. Now girls, look up at what we're trying to do. I'm going to need, we're supposed to show that 4 choose 0 plus 4 choose 2 plus 4 choose 4 equals 4 choose 1 plus 4 choose 3. What do you think I should do here now? Take the negatives to the other side. So therefore 4 choose 1 to negative 1 plus 4 choose 3 equals 4 choose 0 plus 4 choose 2 plus 4 choose 4. So what I've done there, I've just moved the negative ones to the other side and I've proven the result that they wanted us to prove. Then it says, hence, so now it says, hence, we have to show that 4 choose 0 plus 4 choose 2 plus 4 choose 4 equals 2 cubed. That's the next part of the question. So that was B part 1. B part 2 says, hence show that 4 choose 0 plus 4 choose 2 plus 4 choose 4 equals 2 to the power of 3, and it says using the result from part A. Okay. So we have to use this result from part A, which is this, to show that. Okay, what do you think we'll do? Okay. I wouldn't do that, no. Okay, girls, not sure where I had this video paused, so not sure where I've restarted. But we're trying to show this result using the result from part A. So we know that 4 choose 0 plus 4 choose 2 plus 4 choose 4, if we're using this result, equals 2 to the power of 4 minus 4 choose 1 minus 4 choose 3, which is 2 to the power of 4 minus, I'm going to put them in brackets, but I really don't have to, minus 4 choose 1 plus 4 choose 3. Girls, doesn't 4 choose 3 equal 4 choose 1? And what do they both equal? 4. So it's 2 to the power of 4 minus 4 plus 4, which is 2 to the power, what's 2 to the power of 4? 16 minus 8, which is 8, which happens to be 2 cubed. Done. Now, if you go and substitute part B result back in here, you're just going to end up with the same thing. You're going to end up with 4 choose 0 plus 4 choose 2 plus 4 choose 4 equals the same thing. Yeah. So you have to use the result from part A. Okay? Now, I didn't really need to put this in brackets. I could have just gone 2 to the power of 4 minus 4 minus 4. Okay? You have to remember that 4 choose 1 equals 4 choose 3. You know how 3 plus 1 is 4? Remember Pascal's triangle is symmetrical? Okay? So we've proved that result. Part 3 says, now we're going to differentiate. It says differentiate both sides of the identity, and then we're going to substitute x is 1 and x is negative 1. So differentiate both sides of the identity. Yeah, I'm going to. So, C part 1 says differentiate both sides of the identity. Now the identity is 1 plus x to the power of 4 equals 4 choose 0 plus 4 choose 1x plus 4 choose 2x squared plus 4 choose 3x cubed plus 4 choose 4x to the 4. That's the identity. You have to differentiate both sides of the identity. What do you get? How do you differentiate 1 plus x to the power of 4? You bring the 4 down to the front. So differentiate both sides. 1 plus x to the power of 3 times 1. So don't worry about the times 1. I'll put times 1. Equals, if you differentiate 4 choose 0, what does 4 choose 0 equal? By the way, it's 1. If you differentiate that, what do you get? 0. Differentiate a constant, you get 0. If you differentiate 4 choose 1x, what do you get? 4 choose 1. If you differentiate 4 choose 2x squared, you get 4 choose 2 times 2x. So I'm going to write it as 4 choose 2 times 2x. If you differentiate 4 choose 3 x cubed, you get, remember 4 choose 3 is just a constant, times 3x squared. And if you differentiate 4 choose 4x to the 4, you get 4 choose 4 times 4x cubed. Now we've done that. It's said to differentiate both sides of the identity. The next part, 2, said to substitute x equals 1 into both sides to show the result that they're trying to prove there. I can bring it here if you want. Substitute x is 1. If you got the question in front of you? Yeah. All right, good. And we need to show that 4 choose 1 plus 2 times 4 choose 2 plus 3 times 4 choose 4, etc. equals that 4 times 2 cubed. Substitute x equals 1 into the differentiated result. What do you get? 4 times, if you put x is 1 in there, what do you get? 4 times 2 cubed, isn't it? 4 times 1 plus 1 cubed equals 4 choose 1 plus 4 choose 2 times what? If you substitute x is 1 times 2 plus 4 choose 3 times 3. Good. Plus 4 choose 4 times 4. Now, isn't that 4 times, now look at what they're trying to get you to prove, that it's 4 times 2 cubed. We've already got that on the left. So it's 4 times 2 cubed equals, I think we've already got it. You just put the coefficients out the front, is equal to 4 choose 1 plus 2 times 4 choose 2 plus 3 times 4 choose 3 plus 4 times 4 choose 4. We've proven that result. Girls, these are the easier types of these. All right, they're very guided. But all you'll be doing, it says to substitute x is negative 1 into that differentiated expression. What do you get? 4 times. So we're substituting x is negative 1 into this differentiated expression. What do you get? 4 times 1 minus 1 cubed equals, do you know what I'm doing? 4 choose 1 plus 4 choose 2 times what? If x is negative 1, what do you get? I'll call this equation 2. What do you get, girls? If you substitute x is negative 1 into here, what do you get? Times negative 2 plus 4 choose 3 times 3. What happens if x is negative 1? What do you get? Positive 3 or negative 3? Positive 3 plus 4 choose 4 times. If you substitute x is negative 1 into the differentiated expression, what do you get? Negative 4. So, let's see the result we're trying to get. By substituting x is negative 1, you have to show, you can see the result there. What do you get here? What's 4 times this? 0. And here, what do we get? 4 choose 1 minus, so I'm just going to put it as 0. Obviously, it's 0. What do I get here? 4 choose 2 times negative 2. Can I just write it as minus 2, 4 choose 2, plus 3, that's a big 3, by the way, 4 choose 3, what's next? Minus 4, 4 choose 4. Done. Now, so, all we've done, we started with the original identity. Sometimes you just have to substitute. Sometimes you have to differentiate and substitute. If you see where you're trying to show a result with a 2 in it, you're obviously substituting x is 1, because then you get the 2 to the power of 4. If you are trying to prove some result with no 2 to the power of something in it, you're substituting x is negative 1 to wipe out that first term to get 0. All right? So when we were trying to prove this second result, notice there are no 2's in it. That's when we substituted x is negative 1. To get that first result, to get 2 to the power of 4, we had to substitute x is 1 up here. All right? So what you'll be doing is looking at where you want to go, and you'll be able to pick, do I substitute x is 1, or should I substitute x is negative 1, or should I substitute x is 0? You need to look at what you're trying to aim for and then decide on the substitution. At the moment, they're guiding you very much. All right? Now, for part D of the question, it says to integrate both sides of the identity. So the identity is 1 plus x to the 4 is 4 choose 0 plus 4 choose 1 times x plus 4 choose 2x squared plus 4 choose 3x cubed plus 4 choose 4x to the 4. It says to integrate both sides of the identity and show that for some constant you get the result that they've shown. All right, let's go. Integrating both sides. Both sides that they've given us. It says both sides of the original identity. What do you get if you integrate 1 plus x to the power of 4? Don't you get? What do you get? Don't you get all of that to the power of 5 over 5? 1 plus x to the power of 5 over 5 times the coefficient of the x, which is 1, equals. How do you integrate 4 choose 0? Just one sec. Integrate 4 choose 0, what do you get? If 4 choose 0 is a constant. Good. 4 choose 0 x. When you integrate 4 choose 1 x, you get 4 choose 1 is the constant stays there, x squared on 2. When you integrate 4 choose 2 x squared, you get 4 choose 2 x cubed on 3. When you integrate 4 choose 3 x3, you get 4 choose 3 x4 on 4. And when you integrate 4 choose 4 x4, you get 4 choose 4 x5 on 5, plus they want the constant k, not c. Don't worry about it. They want k, they want k. Because, oh sorry, you can put k on both. So that plus k and the other one plus k. It doesn't actually, look, it does not matter where it goes. It doesn't matter. Yeah, but doesn't matter what side. If anything, I could put it on both sides. If I integrate, no, because they could be different constants. All right? I wouldn't. You can put c, and what you can do, if you don't want to put k, you can put c, some other letter, and then say the combination of them is k. It's really no big deal. All right? I'd just go and throw it on one side, because if there was a constant on the other side, you bring it over, it's not going to make a difference. Yeah, it doesn't matter, but. All right? So if you want, put it on the left. Put it on the left if you want, but it really doesn't make a difference. Okay? It doesn't, honestly. Because if you've got a constant on the left and a constant on the right, can't you combine them to make a new constant? So if I call this c and d and bring the d over and say k is c minus d, all right? They're just constants. So if you want, put the k on the left. Okay? All right, so we've got that. They're just showing it as 1/5 as opposed to over 5. So therefore you've got 1/5. 1 plus x to the 5 plus k is 4 choose 0 x plus a half 4 choose 1 x squared plus a third 4 choose 2 x4. No, it's not x4, x3 plus a quarter 4 choose 3 x4 plus a fifth 4 choose 4 x5. So you've shown that identity. The next part is to substitute x is 0. Now, the reason, see girls, once we've done this integration, we need to work out the constant. So whether you've got a constant on the left and the right and then combine them, it's not going to matter. All right, so just put one constant in there. Now, why do you think they're choosing x is 0 here? It gets rid of everything on the right-hand side. Can you see why substituting x is 0? We need to work, you know when you integrate and you get plus c, your next step is to work out what the c is. The only way you can work out what that c is to eliminate all of these terms. And the only way to eliminate everything is to substitute x is 0. So if I substitute x is 0 into that expression, I get 1/5. What do I get? 1 plus 0 to the power of 5 plus k equals, don't I get 0 plus 0 plus 0 plus 0 plus 0? So in other words, I get that k is, isn't that just 1/5? Negative 1/5. Now, if k was on the other side, you get positive 1/5. It doesn't matter. If the, no. So, k k's on this side, k is negative 1/5 on this side. Let's say I decided not to put the k on the left and I put it on the right. My answer for k would have been positive 1/5. I would have got 1/5 equals k. Yeah, no it doesn't, because when k is over here, I write what k is over here. Negative 1/5 on the left, isn't it the same as 1/5 on the right? So wherever the k is, you work out its value and substitute it in there. So it says, by substituting x is 0, show that k is negative 1/5. And we will get negative 1/5 because we had the k on this side. But if the k was on the other side, it would have been positive 1/5. Part 2. Because part 1 said to have the k on the left. Okay? Part 3, look, when you do your own questions, you can decide left or right for yourself. And as long as you're substituting it where it is, this is all guided. Your questions are not going to be guided like this. They're not going to say find k, substitute x is 0. You're going to have to know to do all that. Okay? This is a guided example. Part 3 says to substitute x is negative 1 into part 1. Part 1 above. This is part 1. To get that other result. Let's see what we get. So this is part 1 result here. So if you substitute, see girls, when you integrate that, you've got two options here. If you substitute x is 0, you wipe out all the right-hand side. Do you see that? Wait. And if you wipe out the right-hand side, you'll work out what k is. If you substitute x is negative 1, you're only going to wipe out that thing. But everything else is going to stay there, and you're going to have plus, minus, or minus, plus, minus, plus, minus, plus. Okay? So you've got choices once you've differentiated and integrated. But you've got to decide what you're going to substitute. And you need to look at where the answer's going to decide. So if we substitute x is negative 1 into this, we get 1/5, 1 minus 1 to the power of 5 plus, now we know what k is. Oh, plus what's, yeah, plus negative 1/5 equals, yeah, you just put minus. Just put minus 1/5 equals. Now x is negative 1, what do you get? Can I just put it straight away? Yeah. What do you get? Minus 4 choose 0. Are we okay with that? Yeah. Plus a half. 4 choose 1 times negative 1 squared. Actually, you should really put it in. Put it in. Plus a third. 4 choose 2 negative 1 cubed. Just show you're working. Just show you're working. Plus a quarter. 4 choose 3 negative 1 to the 4. Plus a fifth. 4 choose 4 negative 1 to the 5. Now let's see what, so I've done the straight substitution completely. What do you get? So I've substituted x is negative 1 into that. And I've put what k is in as well. So what do you get? No, tell me what you get on the left. 0 minus 1/5. So minus 1/5. I'm going to put 0 minus 1/5 equals, what do I get? Negative 4 choose 0, plus or minus for the next one. Plus 4 choose 1 x squared. No, not x squared, just plus, sorry, what have I missed out? Plus a half, 4 choose 1, what's next? Minus a third, 4 choose 2, plus a quarter, 4 choose 3, minus a fifth, 4 choose 4. And what's the result? You look at what you're supposed to do. Swap sides. Just swap sides. So therefore, 4 choose 0. So swap sides. Minus a half, 4 choose 1. Plus a third, 4 choose 2. Minus a quarter, 4 choose 3. Plus a fifth, 4 choose 4 equals positive 1/5. Okay, now, oh God. I'm just going to pause. We've got 1 plus x to the n, so we don't know if it's to the power of 4 or whatever. It's just a general one. Is the sum of all terms from k is 0 to n of nck x to the k. Why do you, see, isn't it normally nck, the first one to the power of n minus k, but the first one is just 1, and it's a plus. So you're always going to have 1. Look, and x to the k. So normally it would be nck 1 to the power of n minus k, x to the power of k. 1 to the power of n minus k, and everything's positive, is just going to give you 1, 1, 1, 1, 1, all the way. That's why they don't bother with the 1 term. Okay? No? If you were to write the general term of this expansion, alright, let's say n was 4. What would you have? 4 choose 1 plus. If n was 4, you'd have like the first one. Isn't it highest power, and then the 1 to the highest power, and then no x's? And then you drop a power. 1 to the second highest power, and then bring in 1x. But 1 to the power of anything is always 1. That's why you can't see the 1 in here. It says, prove the following and explain each result in terms of the row indexed by n equals 5 in Pascal's triangle. Alright, it says, by substituting n x equals 1, show that result. So by substituting x is 1, so part A, we're going to substitute x is 1 into that, and what do we get? Substitute x is 1. What do I get? 1 plus 1 to the n equals sum from k to 0 to n of nck 1 to the power of k. Does that make sense? So we start with this. Girls, this is a condensed version of the binomial expansion. Instead of writing out each term, they're saying it's the sum of all terms where you start with k is 0. So the first term would be nc0, x to the 0. The second term would be nc1, x to the 1, plus nc2, x squared, all the way up to ncn, x to the n. That's what that notation means, okay? So if you substitute x is 1, you get that. So therefore on the left you've got 2 to the power of n is the sum from k is 0 to n of nck 1 to the power of k, where k is a whole number and positive, is 1. Well, no, but k is a positive number. But k is not negative. Here k lies from 0 to n. K is from 0 to some positive value. It's only if you had a negative 1 to the k that we would have a problem. Negative 1 to the k, sometimes it will be positive, sometimes it's negative. So that's that first result proved. Okay. Part B. It says, by substituting x is negative 1, you have to show that result. Now, here, by substituting x is negative 1, show this result. Now, it also does say, prove the following and explain each result in terms of the row indexed by n equals 5. So, girls, it appears that they've expanded it. What do you think? What else do you notice? On one side you've got the evens, and on one side you've got the odds. Why is that happening? Because you're substituting x is negative 1, and every second term is positive, and the other every second term is negative. And when you substitute x is 1 into the original expansion, you wipe out the left-hand side when you substitute x is negative 1, sorry. So what you need to do, I'd be writing this expansion out properly. You can't do it just like that. So you need to write out the expansion properly. So 1 plus x to the n, instead of writing is the sum of, can we start writing out some terms? What's the first term? nck, 1 to the k, we don't need. nc0, thank you. nc0, 1 to the n, x to the 0, plus nc1. It needs expanding. Plus nc1 what? X. It would be NC0, yes, girls, it's telling you to start from K is 0. So you'd get NC0, 1 to the 0. All right, why don't we just substitute it into here? Okay? All right, NC0, 1 to the 0 is 1. NC1, when K is 1, 1. Whoa. Here, substitute it into that. There it is. There you go. Substitute into this, not that. So when you substitute K is 0, you get NC0, X to the 0 is 1. So you get NC0. When K is 1, just keep going up to 5 at least. When K is 1, you get NC1, X to the 1. Got it? When K is 2, this is telling you this is the sum of all terms from K is 0 to K is N. When K is 2, you get NC2, what? X squared. Can you see you substituting different values of K into here? Starting from K is 0 to K is N eventually, but we're not going to get all there. Plus NC3, X3, plus NC4, X4. What else? We'll go up to NC5, plus NC5, X5, dot. I'm just going dot, because I don't need more. Yeah, but it will continue. Doesn't that all continue up to NCN? It'll. I know they're not putting an n equals 5 in there, so I think that's. I think they mean by they do. They just want up to the 5th row of the expansion. That's all. They just want up to the 5th row of the expansion. Okay. Now, substitute x is -1. What do you get? So I'm just going up to there, dot. I can stick the last term in, but I'm not going to bother because they haven't got it there. The last term would be NCN x to the n. All right, so you substitute x is -1, and what do you get? 1 minus 1 to the n equals NC0. What would you get if x is -1 here? Minus NC1. If x is -1, what would you get? Plus NC2. Minus NC3. Plus NC4. Minus NC5 dot. Plus dot. 1 minus 1 to the n is just 0, isn't it? So let's just go 0 and bring the negative ones over. 0 plus NC1 plus NC3 plus NC5 plus dot equals, do you know what I mean? That would continue. You'd bring the NC7 over and the NC9 if you had to. So I've got plus dot equals. And should I have done it the other way? I should have. Yeah, I brought the negatives over. Yeah, you always bring the negatives over and keep the positive ones equals what? NC0 plus NC2 plus NC4 plus the next one would be NC6. And after that you'd have NC8. Does it make sense? That's the result that you've proved. It doesn't matter that yours is on the left and theirs is on the right. Okay? So that result's just been proven. You can copy it again. Therefore, NC0 plus NC2 plus NC4 equals NC1 plus NC3 plus NC5 dot. Okay? So that's proven. It then says, hence, by using the result of part A, show the next result. So we have to use the result of part A. I'm just going to write down what we've been asked to show. So let's put A in there. That's A. So this is part 2 of B. So now we need to hence show that NC0 plus NC2 plus NC4 plus a whole lot of other stuff equals 2 to the n minus 1. Okay. Okay, girls. Look at the step before. We've got NC0 plus NC2 plus NC4 equals this NC1 plus NC3 plus NC5. But the sum of everything equals 2 to the n. Now, show that using the result from part A. From part A, we know that 2 to the power of n equals sum of terms nck from k equals 0 to n. So we write it out in expanded form. 2 to the power of n equals nc0 plus nc1, I'm going all the way, dot, 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 up to ncn. Now that result is actually the sum of all terms of coefficients in any row of Pascal's triangle is 2 to the n. So we need to show this 2 to the n minus 1. Now, the sum of Pascal's triangle, these are all the coefficients on any row of Pascal's triangle. And we know with Pascal's triangle that we have symmetry, that the first term in the row is 1, it equals the last term in the row, which is 1. The second term in the row equals the second last term in the row. So NC0 equals NCN, NC1 equals NC to the n minus 1, NC2 equals NC to the n minus 2. So therefore, 2 to the n will equal 2 times that bit off. That's not leading us anywhere because I'm not using the bit from part B. Yep. Good. Thank you. You know what should I be doing? I know that NC0 plus NC2 plus NC4 equals, it still is this double up thing, but I've just gone about it the wrong way. So NC0 plus NC2 plus NC4 equals NC1 plus NC3 plus NC5, doesn't it? So why don't I break this up? So, you know how I've got that first row? I'm going to break it up. Isn't that NC0 plus NC2 plus NC4 plus whatever, plus NC1 plus NC3 plus NC5 plus dot, dot, dot. Do you agree? That top row, if I don't put these end ones, I don't have to. I can, but I don't have to. If I want to add NC0 plus NC1 plus NC2 plus NC3, NC4, NC5, I'm just going to say, well, I'm going to add every second, the evens, and then I'm going to add the odds, right? Why am I doing that? Because, look at part B. Doesn't NC, if you look up at part B, doesn't NC0 plus NC2 plus NC4 equal NC1 plus NC3 plus NC5? So instead of doing that twice, well, I can say, well, it's 2 times one of those sets. Do you get what I'm saying? From this part before, NC0 plus NC2 plus NC4 equals NC1 plus NC3 plus NC5. So let me replace the NC, because we're trying to show that it's all the evens. So I'm going to replace, so that is therefore, so I can go that that's NC0 plus NC2, get rid of the 2, plus NC4 plus NC0 plus NC2 plus NC4 plus dot, dot, dot. Do you know what I've just done? I've replaced the NC1 plus NC3 plus NC5 from here with that. Do you see it? Wait. Equals 2 lots of NC0 plus NC2 plus NC4 plus dot, dot, dot. So that was using the result from part 1 above. Do you see it? So part 1 said that NC1 plus 2 plus 4 equals NC1 plus 3 plus 5. Guys, wait. So now dividing by 2. So 2 to the n over 2 equals NC0 plus NC2 plus NC4 plus dot, dot, dot. Which means that 2 to the n minus 1 equals NC0 plus NC2 plus NC4 plus dot, dot, dot.